Hi Math 34 students. This is Module 5, Example 1. Make sure you first read through the vocabulary on page 103 and then go ahead and turn to page 104 to work through this example. Module 5 is about two-way tables, so we have here an example of a two-way table. The first way of the table is the hair color, which identifies the rows. So on the rows you see the different hair color options for students in a statistics class. Blonde, red, brown, and black. So there's 4 choices, so students would have to identify as one of those hair color choices. On the columns we have eye color, so that's the second way of the two-way table. And the eye color choices are blue, green, brown, and black. So again, just 4 choices. The furthest column over is the total for each hair color. You can see as we add up the rows, this is the total over here. And similarly, the totals for the eye color are down in the bottom row. In the far corner, we see the total 36, which comes from either adding up the columns totals or adding up these row totals. Either way, we get 36. Our first question A asks, how many students in the class have brown hair and green eyes? So in our two-way table, we find brown hair, and we come over to find green eyes, and we see that is 2 students. So we can go ahead and make a note of that. So we can note that 2 students in the class have brown hair and green eyes. Question B asks, how many have black hair and brown eyes? So if we come to black hair and brown eyes, we see that 7 students have black hair and brown eyes. Question C asks, how many students in the class have brown hair? So if we look up at the table, we see students could have brown hair in any eye color. So we come over to the brown hair color row, and if we add up those totals, we see the total for students with brown hair with any possible eye color is 10 students. Question D asks, how many students in the class have brown eyes? So if we look at brown eyes and come down to the total, that's 17 students. And that's regardless of hair color. Question E asks us, what do the values in the bottom row represent? So the bottom row are the totals for each eye color. Question F asks, what do the values in the right-hand column represent? And the right-hand column contains the totals for each hair color. And then there's a note that says, by the way, for any two-way table representing 2 categorical variables, the totals in the bottom row and right-hand column, excluding the lower right corner, are the marginal distributions. So remember from your vocabulary on page 103 that the marginal probability is the probability of just one category. So in this case, our categories are the hair color or the eye color. Question G on page 105 asks, what does the value in the bottom right-hand corner represent? So that's that total of 36. So we can make a note. This is the total of all students. And then the question asks, how did you get this number? Well, you can add up either the rows or the columns. So we can say adding up the rows or the columns give the same total of 36 students. And this is because whether we're counting up hair color or eye color, we have 36 students total. So we are assuming that every one of those 36 students fits in one of these categories. And we said, did you add the values in the right-hand column or did you add the values in the bottom row? And both methods work. So we're going to say both methods of adding the right-hand column totals or the bottom row totals give the same result. Question H asks, what fraction of students in our class have brown hair and brown eyes? And then it asks, which fractions of students in our class have green eyes? So you can look back at the table to find this data. So brown hair and brown eyes is 5 out of 36 students. And then green eyes, that's the total for the whole green eyes information, is 9 out of 36 students, or we can reduce that to 1 out of 4. And you'll notice brown hair and brown eyes is more specific, right? That's an example of a probability where we're asking for two conditions. The first condition being brown hair and the second condition being brown eyes. So if you look back at your vocabulary, you see that this is the joint probability where the two categories each take on the specific value here. The person has to have brown hair and brown eyes. Question I asks, suppose the number of students in the class with blonde hair was the same, but the total number of students in the class was actually 500. Would reporting the number of students with blonde hair still mean the same thing? So let's think about this. For a total of 36 students, 6 blondes out of 36 total equals 1 out of 6, which if we think about that as a decimal is 0.167. Now if we switch to a total of 500 students, 6 out of 500, well, we could reduce that to 3 out of 250. And if we make that a decimal, that's 0.012. So the decimal, if your total is 500, is much smaller than if your total is 36. So remember, whether we're talking about the fraction or the decimal, we call this the proportion of students. So now the question is asking us to explain why or why not. So in our case, we're going to explain why these are different, right? So the larger denominator from a larger sample makes the 6 blondes a smaller proportion in the larger sample. So the larger the sample size, if we don't change the numerator of the fraction, we're going to get a smaller proportion. So the way to make the difference evident is to compare the proportions and not just those raw numbers of 6 blondes. So we say when comparing two samples of different sizes, we use the proportion, which is the part out of the whole, and you can write that as a fraction or a decimal, and not just the raw data. So go ahead now and practice two-way tables in your group assignment, and remember to post your discussion questions in the group forum related to the group assignment.